A house of quality is an analysis technique for doing something that's very, very important in engineering. At different stages of the life cycle, we need to convert what we're going to do into how we're going to do it. And that's what this matrix is all about. It's referred to as a house of quality because it's a series of interlocking matrices, which, as you can see here, when assembled, tend to look like a house. That's the origin of the term. There are things that a house of quality is good for, and there are things that it doesn't do. What it does is it rationalizes and traces requirements from one level down to the next, the what to the how, and it establishes not only priority, but it creates a metric or a measurement mentality around each of the requirements. That's what house of quality is good at. What house of quality does not do is your general engineering for you. So you're going to see we have to fill things in the different rows of these matrices. We have to fill things in certain columns of the matrices. House of quality is not about figuring out if those are the right rows and columns. That depends upon other engineering techniques that you're going to use. So the house of quality is used late enough in your life cycle or late enough in your phase that you already have a pretty good idea what belongs in the rows and columns as you go through. But that engineering happens outside. So be careful about overclaiming what a house of quality can do. It's about prioritization. It's about triangulation. It's about measurement. It's about traceability. But it's not about the baseline engineering as you go through. So let's just go through some of these matrices to see what can be contained in them as we go through. Okay, that far left one is where we identify our customer needs. Those are the what's. The rows are the what's, the columns are the how. We often see in the literature, like on this slide, the rows are referred to as the requirements, but that's a relative term because a house of quality is about turning what into how. So it could be that the rows are going to be high-level requirements and the columns are going to be basic process components. It could be that the rows are process components and the columns are going to be the functional components. It could be that the functional components are the rows and the system components are going to be the columns. So rows and columns here doesn't necessarily mean technical or non-technical. It's turning what's into hows. In fact, the way I gave the example, we want to turn each of those layers into each other. The process of putting these together to go through more than one level is called quality function deployment, where this gets used. But this isn't a video about that. We'll talk about that later. A house of quality just turns what's into hows. So the first thing we would do is capture those what's, the voice of the customer, in our different rows. On the far side, we have what's referred to as the planning matrix, where we take a look at those things and try to help prioritize them and make them measurable over time. So the planning matrix captures a series of parameters that help us understand what we should be thinking about in terms of the priority of the different things we put in our different rows. So the planning matrix really says, what does our customer need? How would we prioritize them? How are we going to meet this need? How would we measure it? Things of that nature. So it starts with an importance to the customer. For every row, we establish what the importance to the customer is in terms of typically a 1 to 5 scale. We look at the level to which our customers are already satisfied with what they have in their current system. Usually you'll get low scores there. If customers were satisfied with the current system, you probably wouldn't be engineering a new solution. But there could be aspects of the current system that they're quite happy with that you're not going to have to put quite so much time into. You also measure how well the competitors to what you do in your organization, and competitors is a relative term, obviously, but how do your competitors tend to satisfy this requirement? Because you want to make sure any system you put in place not only satisfies your customers, but does so better than the competition that you would view as you go through. And then what's our performance goal? How good do we want to be at this? And that's a subjective judgment. So you as an engineer can't always fill in all these values. You have to work with your stakeholders and your customers to decide how they want to rate the different factors. But given those factors, if you multiply the customer satisfaction score to the performance goal, you can come up with the improvement ratio of what you're looking to do. Is it a huge improvement or a low improvement? Going from a 1 to a 5, like in this example, requires a great deal of improvement going through. You also tend to rate what we refer to as the sales point. Some people call it the fudge point, as though this is somehow artificial. But the reality is meeting certain requirements, meeting certain needs will give your organization or your stakeholder bragging rights. It's the kind of thing you'd put in a marketing brochure for the company to say, hey, we can do this. So the sales point says, let's put some emphasis on those things that will help the organization deploy something. It's a multiplier. So typically we use the values 1, maybe 1.2, 1.5. Don't put a huge value here because it exaggerates the value of sales points. But if you multiply that times the improvement ratio times the relative ranking to the customer, the importance, you come up with a raw score for that item in the planning matrix. You can then calculate a normalized percentage of how important is this row compared to all the others and even rank them going through. So you're able to find out what are the most important components of what we put in the planning matrix for planning purposes. And you want to know that as an engineer as you go through, so you focus a lot of your time on the more important aspects of your system, given that you're bound to have constraints on your project that will tell you you're not going to do all of your requirements because of resource constraints. Some of them will be deferred to a future activity or a future phase. So make sure your initial phase emphasizes those things that are actually important to the project given these criteria. You also want to make sure you understand going into your project, how would you measure whether this requirement is being met or not? If you don't know that, you don't really understand the requirement. And do you have an objective or a threshold in mind today that will allow you to know what you're looking to do? A key element of systems engineering is that you never proceed to the next level of analysis until you're sure how you're going to validate what you've done at this level. So this planning matrix gives you those kinds of measures and metrics that you can build into your acceptance plan as you move into the next stage of your design. From there, you get into the technical responses, the center of the house, the core piece coming through, where you can really establish what some of those design variables are for meeting those. So where the rows are about the customer stakeholder, customer at this level of detail, whatever that is, the columns are about the producer's thresholds and designs going through. So we're typically looking at how are we going to satisfy the what's that were in the row. And again, that satisfaction is going to be more technical than what was in the rows, but it's just taking you to that next stage as you go through. So then we establish the relationships between those. For every design variable we said we need in a column, we relate that to the different what's on a strength scale. If it's a really, really strong connection, this design really supports this requirement, we give it a high score like a 9. If there's no effect at all, this design variable doesn't impact that requirement, we leave it blank or give it a 0. So we're assigning a relationship scale to say, to what extent does the design variable support the requirement? Or looked at the other way, for every given row, looking at our requirements, our what's, do we have a how that satisfies them going through as we see our way fit? You can review the results as you do that. If you end up with a matrix where you've got an empty row, meaning you've identified a what, but there's no how that addresses it, you're probably not done. Likewise, you could have unnecessary measures. If you've got a column that you've added in that has no relationship to any of the requirements, you have to ask yourself why that's the case. Is it something I really don't need? Which often isn't the case. If you put it in the design, chances are you need it. What it usually indicates is that you're aware of a requirement that hasn't actually gotten captured yet. There's a missing row that would have been a strong fit to your unnecessary measure. So don't delete the unneeded columns. Figure out why you put it there in the first place and go document that what. So you're constantly massaging this matrix until you're going through. And avoid the kind of the crosshatch, the diagonal, if you will. If all you get is a diagonal of high scores, that means someone didn't really do their engineering. They just sat down and said, we need a measure for each of the requirements. All you've really done is you've translated the requirements into a slightly more technical version of themselves, and that's usually an indication of bad modeling. But you want to spend a lot of time conducting that kind of quality control. As I said when I started, this technique doesn't guarantee you have the right rows and columns. It just allows you to prioritize them against each other. So beware, garbage in, garbage out. But assuming you've come up with good what's and good how's, you'll be able to do this kind of mapping very, very effectively as you see your way through. In the attic of the house of quality is where you look for the interactions of those kinds of things, the correlations between them. So if you've got different design variables that impact each other in either a positive or a negative way, you want to document that so you can do some trade-off analysis. If you want high usability as one of your design variables, but you also want high efficiency as another design variable, often those things are in conflict with each other. So watch for that as you do that and document those in the attic. And down in the basement, we start to do the equivalent of what we saw on the far right side of the planning matrix, start documenting what those technical impacts are and what their values are going to be. So what's the raw contribution of each going through? What's the normalized contribution and what's the rank? So in essence, by Having a matrix where you equate the hows to the whats through that 1 through 9 scale, you're able to basically add up the weighted scores to figure out which are the more important hows. So we calculate what are the most important rows, and we use the association matrix to use that to determine what are the most important columns. Change the prioritization of the rows, you would obviously change the prioritization of the columns. But for as long as the matrices are stable, you'll know now what the more important technical impacts are in your house equality. So those basement scores can be calculated to really tell you what's going on in your design variables that really needs to be addressed over time. Okay. So the target values you set become the target values you then use in your design, and you move forward based on that. So if someone then challenges, why are you designing to these target values? You can point back to your house equality and say, because based on our analysis in the house equality, these are the design variables that will best support the highest priority requirements that we were given over time. So it's heavy on traceability of requirement, what to how, and it's heavy on being able to measure and have a rationalized measure of what's going on in terms of those target values over time. So you end up with some kind of a matrix that's telling you what the important features are. You're then going to take those features eventually and continue to work on them and do the rest of your engineering over time. So this matrix isn't about your entire engineering, but it's about a key component of understanding the relationships among the components in your engineering. So your finished matrix, when you're done, can be quite a massive undertaking. There are tools for doing this, and there are spreadsheets that you can build to do that. And often I do mine in Excel, but there's certainly QFD tools out there that you can get and use as you go through for keeping track of all of this. But if you're basically fairly strong in Excel, you'll find you can do a lot of the work there.